recording, and I'm going to share the screen, so it should be the camera here. So I hope you can see the screen now, okay? All right, okay, this will not be a long session because we have actually finished the syllabus last week, yeah? And I did mention this. So everything that I needed to cover, we covered in the past, okay? Did we do the square slab last week, isn't it? Yeah, isn't it? Yeah, that was it. So I think we covered everything that I intended to cover for this syllabus. The other thing is, your exam is not next week, the week after, so it's your only week-ish from the exam. Is it the 9th? I think it's the 9th, isn't it? Check the timetable for your exam. I think it's the 9th of December. So you're not looking, you're looking probably for, I think it's the 9th, if I remember, isn't it? I think so. Yeah, so you're looking at really about 10 days, 10, 12 days, okay? That's all. So you need time to revise. So what I'm planning to do today really is a question answer session if you have any questions, and I'm going to just go through some of the revision of what the kind of stuff that you need to know or prepare for the exam. Okay, so I'm going to do that now, and you can, if you have any questions, you can always interrupt me. Okay, so revision. So I'm just going to take you through the journey from what we started to this, okay? So plastic, we started with the plastic theory of structures. Yeah, this is where we started. We started with the plastic theory of structures. And what we did, the first thing that we did was obviously to define what the problem is, the assumptions and so on. And one of the things that we did first was to actually learn how to determine MP for a section. And this is the first thing that you need to know for your exam, is how do you determine the plastic moment for a given shape. So if I give you a T shape or an I shape or an L shape or whatever shape you have, or a tubular shape, any shape that you have, you need to know how to determine the plastic moment MP for a section. Okay, and we did a number of questions. I think we did a T section. We did a, if I remember, we did a channel section. So yeah, so we did I think a few examples, and I think I've uploaded 1 or 2 examples in Aula. So what you need to understand the steps involved in determining MP. The main thing about when you determine MP is to determine the, what do you need to determine in order to determine MP? The equal area axis, exactly. That's what you need to remember, yeah? So if you are given any shape, what you need to know, how to determine, well, I'm sure you know how to determine. So basically what you need to determine the equal area axis, and that equal area axis, using that equal area axis, you can then determine MP. For example, if I give you a T shape like this, let's say you have a T shape like this, okay? And obviously this is a section which is not symmetrical, okay? So the chances are your equal area will be somewhere here, right? That will divide your section into 2. So you have, this is area A1, this is area 2. So if you are given a T shape like this, what you can do, you can say, okay, I'm going to call this here X, okay? And I'm going to put this area equal to this area, because you know everything else. So basically, let's say this is 10, let's say this is 10, okay? Let's say this is, for example, 80. Okay, for example, 80 here, okay, and let's say this is, for example, okay, let's say 100, okay, depth, for example, okay. So you know everything, and you can determine X from this here, because what you can do, you can say, okay, you can say 80 times 10 plus, okay, plus x minus 10 times 10, you agree? Equals, okay, equals what? This area. What is this area? 100 plus 10, 110 minus, do you agree? Yeah, times 10, that's it. So you have got only one unknown here, and that will give you x. So it's very simple, okay? And you can do this for whatever shape you have, okay? Always the same process. So you determine the equal area, and then once you've got the equal area, and once I know this here, so this is now my T shape, okay? Sorry, it's not very good. So this is my T shape. I know exactly the equal area, and therefore this is my stress diagram at collapse, okay? And then you can determine the rest. Is that clear? But that will give you your MP. So you determine C and T, and then your MP will be C or T times this distance. And that's what we did, all right? And you can do this for a channel, T-shape, I-shape, regardless, okay? Always you go for the equal area axis, and that will give you the stress distribution diagram at plastic, and then you can determine C and T from geometry, and hence you can get MP. The other thing you need to know is, or the other thing we did and you need to know is how to determine the shape factor. The shape factor, okay? That's the other thing you need to know, is how do you determine the shape factor. The shape factor simply, if you use the definition of shape factor, alpha, what is the shape factor definition? Don't look at your notes. Your exam is tomorrow. Sorry? MP over my. I mean, the good thing about your exam, it's actually open book, isn't it? So you can check everything, right? So MP over my, yeah, yeah. Or what else? Or S over Z, exactly. Yeah. So we've got MP. So your first step, you have already done MP. Now, my suggestion to you is this. You can get MY by going to the basic, triangular distribution of stress, right? How do you get MY? You can get MY by, what is it that you need to know? Let me ask you the question. What is it that you need to know if you want to calculate MY? Let's say I want to calculate MY or Z. I mean, we can use this.
You get to neutralize.
What do you need?
You get to neutralize.
Exactly. So in order, I mean, what you can do, you know that MP is S sigma Y. Yeah. So this here, because you know MP, you can get S immediately, right? By dividing MP by sigma Y. So I've got that. So I've got this one. I need to know what Z is. In order to get Z, right, you need to determine the centroid of the section. Okay, so you need to determine the centroid of the section. So this is your T section. Is it gone? Oh, sorry, I'm sorry. So you need to know, actually I use a, so this is your shape here, this is your T shape, okay? Right? And, sorry, and you, and then what you need to determine the centroid, which will be somewhere there, okay? Are you all comfortable with determining the centroid of shape, any shape? You are all comfortable? Because you need to do that? Okay. So, I mean, it's very simple. You can use, I mean, usually, if this is the Y, if this is the X-axis, if this is the Y-axis, okay? All you need the Y coordinate. Yes, you need the Y coordinate. And if I call this here Y bar, okay, which is the coordinate of the neutral axis, the equation is sum of AI, YI over total area, okay, of the shape. All right, and what is A? So basically you can divide this shape into two. So I've got area A1, I've got area A2. This is the centroid for A1, and this is the centroid of A2, isn't it? So this is Y2, this is Y1. You always keep it to the same axis. So this is what, okay? So basically, you know Y1, you know Y2, and you use this equation. Simple. Okay? So A1 times Y1 plus A2 times Y2 divided by the total area. That's it. That's your centroid. Very simple. Is that clear? Yeah. Then Z, in order to determine Z, what is Z by definition? I over
Y.
not any Y, Y max. This is important, and this is a common mistake that a lot of people make. Y max is either, because it all depends on the shape, okay? In this case, it's obvious that Y max is actually this Y bar here. Basically, okay, let me put it this way. Y max could be this here, or it could be this. It depends on the problem, okay? So Y max is the maximum distance from the centroid to the outside fiber. So it could be to the top, it could be to the bottom. It all depends on the shape and the dimensions. Is that clear? Okay, so your Y max is not necessarily your Y bar that you have calculated. It could be this one. Does it make sense? Yeah. Okay. So anyway, so you know Y max. So the only thing we need to determine here, I, which is I about the neutral axis. Okay, this is second moment of area about the neutral axis. So you know, in this case, I will be I of shape 1, okay, plus I of shape 2. Simple. Okay, so you have your BD. Do you know parallel axis still?
Yeah.
BD cubed over 12 plus A times the distance squared. Okay, so in this case, I1 will be basically BD cubed over 12 plus, I mean in general, it's BD cubed over 12 plus A times distance squared, where n will be the distance between the centroid of the section and the centroid of the I mean, if it's A1 or A2, of A1 or A2. In other words, for example, for A1, it will be BD cubed over 12 plus A1 times this distance from this centroid to the centroid of the section squared. And then for A2, for this one here,
the center of the whole section.
yes. And then for A2, it will be B. Okay, I repeat again, for A2 here, it will be B D cubed over 12 plus area A2 times this distance, which is from the centroid of the shape as a whole to the centroid of the section under consideration, squared. Clear?
Yeah.
That's it. All right? Okay. Yeah, and that will give you I, and then what you do, you divide your I by the Y max, and then once you've got Z, you go back to this equation here, and your shape factor will be S over Z. When you get Z, when you get the shape factor, it's very human to make mistakes, okay? But if you get silly answers for alpha, at least go back and check, okay? Say you get alpha 12, would you accept it? You will not accept it, isn't it? Yeah? You know your alpha will be Could be 1.5, 1.8, 2.1, 2.3 maybe, but not like 10 or 12 or whatever. So if you get very large values for alpha, which happens quite often in an exam setting where people make mistakes here, it's very normal, then always question the, reflect on the answer that you get. And if you get anything that looks really not out of the ordinary, you should question it and check your answers. Maybe you can go 1 or 2 steps back and check it, okay? So if you get a sensible answer, then it gives you some confidence that, what you're doing is right, okay? Is that clear? So this is the first part of the exam if you want. You will be given a shape, and that's what you need to do, okay? You need to, you may be asked to work out MP or the shape factor or both, okay? Any questions on that? Is that clear? So my advice to you is just go back to the questions we did, the channel, the T section, etc. And there are a lot of questions on the website, so you can pick a tutorial question from the internet or Google. Just go Google it. You can put shape factor of sections. You get plenty. So you can practice on few, and then you can check your answer. That's a good way of doing it. Okay. You don't need to know all of them. I think if you practice on a T shape, on an I shape, on a channel, and one tube, that should be fine. Okay, because they are all the same anyway. Is that okay? So that's the first part of what you might get in the exam. Okay. The second, then after we covered the MP and shape factor and so on, the next thing we did was to actually to carry out the plastic analysis, okay, of structures. Okay, and what we did beams and we did frames. That's what we did, isn't it? And frames, we did rectangular frames, and we did pitch roof, isn't it? Frames. And beams, we did one span, or you can have continuous. And that's what we did, okay? And we covered examples of all of this, okay? We did rectangular frames with different shapes, symmetrical, asymmetrical, with different values of MP. And then we did the same with the pitch roof frames. We did symmetrical, asymmetrical, different MPs and so on. And then obviously this is where we started. We started with beams. We did this one span beam, fixed at both ends, and I think we did optimization for prop cantilever. Do you remember? Yeah. And we did a continuous beam where we have 3 nodes, I think. So we've covered all the these here. And any examples that you get is really just changing values, changing loading and so on. So they are all the same. They all follow the same steps. So what I would say just go through the examples that we did in class, and you will be fine. Okay. So you will get a pitch roof or rectangular or continuous or one span. That's all I can tell you. Okay. Yeah. So just revise this here. Okay. And I think I did upload last year's example, isn't it? Last year's exam and the year before. I think there are 2 exam papers. Yeah. So it gives you a flavor of what you expect. So that will be, if you want, that will be question number 2, plastic analysis of a structure. So you will be given a frame or a beam that you analyze using the plastic analysis. Okay. The key thing about the plastic analysis of structure is to understand the mode of the collapse mechanisms. That's all. Okay. So and what you need, it will be very helpful to always use the rules to guide you. Okay. So M is the what was M again? Number of plastic hinges. Do you remember? Yeah. So M is the number of plastic hinges, and N will be the, what was N? Yeah. Degree of redundancy. Yes. And then you have N, capital N, which is M minus N, gives you the number of number of independent mechanisms. And then you have n plus 1. What does it give you?
Number of plastic hinges.
Number of,
Plastic hinges.
yes, not
collapse.
plastic hinges for
Collapse.
total collapse. These are very important, okay? Because it tells you how many hinges that you have got to actually give you total collapse. All right? And it tells you also how many independent mechanisms that you have. So when you determine the independent mechanisms, then obviously what you need to remember is you need to analyze also the combined mechanisms, okay? So you do the independent and then you do the combined mechanisms, okay? The difference between, for the beam mechanisms, all you have only beam mechanisms when you have beams, okay? But when you have frames, you have beam mechanisms as well as sway, as well as potentially what you could have is part sway, in the case of this, isn't it? Okay, so you have part sway, you have sway, part sway, beam mechanisms, and then you obviously you have the combination where you have a beam mechanism with the sway, etc. Is that clear? Yeah, and as I said, I think you have got really a lot of examples really to go through to understand this, okay? So you've got a lot of examples, so I suggest you go through these examples, and I think if you revise, if you do 2 questions or 3 questions of each, you'll be fine. Again, if you find that you want to do more than I've given you on the internet, you find a lot of examples of frames and so on. Okay, so you can take do so. If you finish early your revision, you can always look into the internet and get some more examples. Okay. Have you got any questions on this at all? Is that clear?
Sir.
Okay. Yes.
So the question 2 will be either on beam or frames.
Yes. You get.
I have issue with
both. Yes, you get either a beam or a frame.
I have issue with roof frame. I don't know. The roof frame. I have an issue with it. I say I have issue with roof frame.
I can't tell you. You have to revise. It could be picture frame or rectangular frame.
Yeah, picture frame.
The only difference is the geometry of the picture frame. Yeah. If you remember, we talked about the geometry, how you extend the lines and so on. Okay. But in terms of analysis, there is nothing new. It's the same theory. Okay. So what I say, what I was saying, revise these examples, okay, and you should be fine. Okay, we're not talking about hundreds of examples. We're talking about maybe 7, 8 examples for all of them. That's what we did. Okay, is that okay, everyone, please? So that was the what you need. So that was the for plastic analysis. Yeah, the other thing you need to know. Sorry, the other thing you need to know is once you have determined the the critical mechanism, what do you need to do when you determine the critical mechanism? What would be the next step? So you have done your, let's say you've got a rectangular frame, so you've got a beam mechanism which gives you some value for the load. Then you do a sway, it gives you a value. Then you do combination, it gives you a value. Okay, so from that you get the critical solution, isn't it? Yes. So what do you do then? You need to check, because you need to check that this is it is the true solution. Always you must know that. Okay, and in order to check that it's true solution, usually what do you need to do? Usually
Change
the yield, isn't it? Because the mechanism condition is fine, the equilibrium is fine, because you say external work equals internal work, so that's okay. So usually what you need to check the yield condition. Check the yield condition. How do you check the yield condition? Usually what you have, in order to check the yield condition, you need to check that moments everywhere are what?
Less than MP.
Exactly, less than MP or equal at the maximum, at the minimum. Okay, so that's what you need. You need to check. So you need to check that the moments everywhere in your frame or beam are less than MP. And then once you've done that, once you have checked the yield, then you can say this is the true solution. The next step will be, sometimes I do ask for drawing the bending moment diagram. Okay, and we did examples for all cases. We did examples for beams, we did examples for rectangular frame and for portal frame, picture frame, on how to determine the bending moment diagram once you have determined the solution. Okay, and we went through this in detail. And that will complete, if you want, the second question, which is, as I said, either beam or a frame where you analyze the independent mechanisms, the combined mechanism, obtain the critical solution. Then once you've got the critical solution, you check it, that it's the unique true solution, and then you can draw the bending moment diagram for that.
Hello, sir.
Yes.
You said when you check that the bending moment in every area is less than MP.
It's the yield condition. One of the conditions that you check, there are three conditions. If you go back to your lecture notes, we said in order for a solution to be true and unique, three conditions must be satisfied: mechanism condition, equilibrium condition, and the yield condition. Usually in our case, the mechanism and the equilibrium conditions are not a problem. Usually it's the yield condition that needs to be checked. And therefore you need to check the yield condition. And the yield condition means that the moment everywhere or anywhere in the frame or the beam, the moments must be less than MP at every location. Okay? Because that will satisfy that your solution is the true solution. Okay?
So when is it lower bound solution?
Sorry?
I said, when is it lower bound solution?
Oh, lower bound solution is the lower bound solution. Okay, what's you answered that question for me?
Yes.
Okay, when is it lower bound or upper bound solution?
Lower bound when is yield and equilibrium is satisfied.
Yield and exactly. Okay, so when you have got the equilibrium is always satisfied. Okay, that's okay. Now you've got the other two conditions: the equilibrium, the yield, and mechanism. So if the mechanism and the yield are satisfied, if the equilibrium and the mechanism are satisfied, and not the yield condition, so what solution is that? An upper bound solution. All right, an upper bound. And if the yield and the equilibrium are satisfied, but not the mechanism, you have a lower bound solution. Okay? Oh. You do that usually if you don't know the exact location of a plastic hinge, which is what we did with the propped cantilever. When you have a propped cantilever, you know there is a hinge of the fixed support, but you don't know the exact location of the hinge on the span. That is a good example where to use the upper bound and lower bound solutions to give you a range rather than the actual solution. It gives you a range between an upper bound and lower bound solution. So if you want to know about lower bound and upper bound solution, what I suggest you do, you look at the example that we did of the propped cantilever. Propped cantilever. Yeah, the product cantilever example is a good one for the upper bound and lower bound solutions. Okay, and you get a range for that. So yes, sorry, I mean you need to revise that, obviously. Okay. Any questions? Okay. Yeah. The final part, which we have been covering for the last 2 or 3 weeks, I can't remember, was, what was it? Yield line theory, isn't it? Or yield line analysis or theory of reinforced concrete slabs. That's what we did. That was the last chapter, and that will be your question number 3 in the exam. So you have a question on shape factor and etc. You have a question on plastic analysis, which can be a beam or a frame, and your third question will be yield line analysis on a slab. And what we did for slabs, I think we did. You can have different shapes. I think last week we did the rectangular one, isn't it? We did the square one.
Triangular.
Yeah, we did the triangular one, which was an awkward shape. We did even the actual shape we did was extremely difficult because it's not a regular triangle. If it was a regular triangle, it would be a lot easier. So we did that. Okay, so we did really all the possibles. I think we did even a circular. Yeah, we did the circular one as well. So we've covered all the shapes. So all I'm asking you, please, is to go over the examples that we covered in place. The only thing that will happen in exam setting is for maybe changing the boundary, conditions, the support or whatever, or the dimensions. But really, everything that you need to know about slabs using the yield line we have covered in class. Okay, I'm not going to give you any awkward trapezoidal shape of of a slab or a hexagon or whatever. You will get a standard shape. You get a standard shape. Okay, you get a standard shape. So all you need is, as I said, understand the steps that we've done in class, and that's what you get. You get one of the shapes here. Is that okay? Yeah. So just cover the ones that we did. So so that's for the slabs. It's quite simple. You get a slab. Sometimes I ask you a specific question to get M or W, whatever, and sometimes you do optimization, which is the case we did last week, where we had a rectangular slab, isn't it? So that's a possibility. But the analysis itself, we have covered for each of the methods. I will not give you anything awkward. It will be one of the shapes that we have covered in class. Is that clear? Yeah. I think it's the good news. I've never had people really failing the exam for at least the last 5-6 years. Even when it was closed book and 2 hours invigilated and everything. So don't panic or anything. It will be perfectly doable because we've got all the material, especially in your case because it will be in front of you. So you have an added, bonus there. Are there any questions you want me to answer? Is that clear? You start your revisions. If you've got any questions, you can always email me. Okay. If you need a one-to-one through Teams, that way you need something to explain, you need something that you want me to explain, just drop me an email and say, can we arrange a one-to-one? And then I can book you for a slot of 10-15 minutes for you to ask any questions. Is that okay? So between now and the exam, you are more than welcome to come back to me with any questions that you have. So start your revisions because you haven't got a lot of time. If you get stuck with anything, please do ask. Okay? You may wish to work together. That's fine. Not in the exam. I mean, when you are revising. Okay? I forgot to mention something. You can't work together in the exam. So I'm telling you this so you're not taken by surprise. It's randomized. So you'll not be getting the same values. Be careful. Okay? You will not
Hello,
be getting
sir.
the same values. The questions are randomized. So you'll have slabs with different dimensions. You will have frames with different whatever dimensions, MPs or whatever. Okay? So they are the same, but the values are different. So be careful, because I had this before, where students were, taken by surprise. So I'm telling you this now, that the exam questions are randomized. So I would not advise you to work together, because you will be wasting an awful lot of time, and then you run out of time when you start doing this. Okay?
Hello, sir.
Yes.
So when is the exam?
When the check the online timetable. I think it's on the 9th. I think it's the 9th of December.
Okay, the timetable is already on the Ola.
Are we? No. The exam timetable is not in Aula. The exam timetable will be in the student portal.
Yeah, go to Nova.
Yeah, go to Nova or go to the student portal, and as soon as you click on the student portal, you will find on the left-hand side menu, scrolling down, you find the exam timetable. Okay? If you can't find it, send me an email and I will send you the link. Okay? But I think it is the 9th of December. Okay? It's on the 9th of December. And you have 4 hours. When you start the exams, you have 4 hours. It's from 9. The exam will be open from 9 to 10 p.m. Sorry, 6 a.m. to 10 p.m. because there are students who are abroad. So we have to cope for the difference in time. But when you start the exam, you only have 4 hours to submit. So be careful. Is that okay?
Okay.
I think, yes.
Are we going to write on paper, because I don't know the nature of the exam? Are we going to write on paper and scan and upload?
What's the question?
Are we going to write on paper, snap, and upload?
Yeah. I mean, you do whatever you want. If you want to type it. If you want to handwrite it and then take photos with your mobile or whatever, or you have an access to a scanner, it's entirely up to you how you do it. Okay? You can do it handwritten. The only thing I would say, if you handwrite, please make it clear so I can see what you're doing, please. Okay? And also show the steps of your working. Okay? So I know exactly what you're doing. So it's entirely up to you how you do it. You can do it on handwritten and then scan it or take photos with your mobile, provided it's good quality. Please don't take photos that are bad quality. Make sure it's good quality so I can read it and I can mark it. Okay? But you do what you want. Is that okay?
All right.
Yeah. I mean, you have a lot of time. The exam normally it's 2 hours. That is how we used to do it before the pandemic. The exam is normally 2 hours. The reason we give you 4 hours is because of that. Because if you handwrite it, and then you have to take photos with your mobile, and then you have to, copy it over to PDF or whatever. So it takes time. So we give you a 2-hour allowance, really. But the exam, really, you should finish it in 2 hours. I can tell you now. It's not difficult. So, but you have allowance to scan. So please don't submit late, because we give you 2 hours allowance. If you are late, you will be penalized. Okay? So when you start, put a clock or watch in front of you. 4 hours, you have to submit. The computer will not remind you. It doesn't remind you. You have to keep an eye when you have submitted, what time you submit. And don't leave it late, because unfortunately, sometimes because when you submit, it takes you through eternity. All right? And sometimes you have noticed it's very, very slow loading it. And I had students who submit in the last 2 or 3 minutes, and then it keeps loading, and then the submission comes through late. So don't do that. You've got 2 hours. Why leave it in the last 2 or 3 minutes to submit? See what I mean? Do it early, check everything is fine, and then submit it. Yeah, submit. My advice to you, submit like at least 15 minutes before the time. So if there is a slowness in the system to upload it, you'll be fine. It's okay.
Are we going to can we do it from any place, or are we going to be coming to school to do it?
If you want to do so,
He said, can we do it from anywhere or we have to come to school?
No. You can do it from anywhere.
Yeah, it's the same question on Monday.
You can do it from anywhere.
Yeah,
I mean,
because
some students, I tell you, some students prefer to do it at the university. I tell you why. The only reason is because you've got access to a photocopier and scanner. You see what I mean? So once you've done everything handwritten, if you use the photocopier here, you scan your your sheets as a PDF, and then it's a lot quicker. And then you can send it to your email, and then you submit. That's the only reason. Okay, which I would advise if you know that you may run into difficulties using your mobile to take photos and so on. I would advise you that you find a place where you can actually have quietness, it's quiet, and where you have maybe access to a scanner. It's not essential, but if you live local here, I would advise maybe that you come to university. But it's up to you. We have no requirement. You can do it from home or whatever you want. Okay, but for purely logistical reasons, if you want to do it in the university, you may find it a little bit easier. Is that okay? Yeah.
is there going to be lecture tomorrow?
Yeah, I mean, it's up to you. I mean, some students, they prefer to do the exam in the library, for example, because in the library it's quiet. You don't get anyone disturbing you. You've got you've got the photocopy machines in the library, and it's really quiet. Rather, if you go to other buildings like Jaguar or whatever, it's a bit noisy. Yeah, you don't want to get distracted in the exam. So if you want to come to university, go to the library. It's a much better place. I think you can book space in library, isn't it?
Yeah.
Yeah. So
Okay.
so I mean, you've got 2 weeks or 12 days. If you're planning to come to uni, my advice: try to book a space in the library. Even if you don't turn up, they don't mind. But at least you've booked it. So book your space because it will be really, really quiet, and then you can work there. Is that okay, everyone?
Okay, there are scanners in library.
Yeah, there are scanners because you use the photocopier. You can use it to scan documents. Yes. Okay.
Okay.
Right. Okay. Good luck, everyone.
Is there
for your
going to be
exams. I don't know if
lecture
you have 3
tomorrow?
exams, isn't it? 4 exams. So you've got soil, this management.
Soil is distress.
Oh yeah. Yes.
Hello, sir. Is there going to be
Okay.
lecture tomorrow?
Yeah. Okay. Okay. Thank you very much, everyone. So good luck with your
To have
exam.
lecture tomorrow, sir.
Sorry, my hearing is not very good on
Are
this.
we having class tomorrow?
No class tomorrow. We finished. We have finished. So what you do, start your revision now. Yeah, you've got a lot to do. Going through all the examples for each of the questions. You've got 3 questions, as I've said. Go through them carefully. Take your time. Everything that you need is there in the lecture notes. Everything that you need is in the lecture notes. Okay. All you need is go through them, and then if you get stuck, come back to me. Okay. So I'm going to stop the recording now. All right.